Williamson's ether synthesis. Alkyl halides react with the sodium ethoxide to give ethers. Right? Alkyl halides react with the sodium ethoxide to give ethers. R, O, R. Right? I give an examples also. Right? Am I audible? Is it clear? Voice, everyone. Right? See, very important condition in the Williamson's ether synthesis. R dash should not equal to vinyl group. R dash should not equal to vinyl group. R dash should not equal to aryl, and R dash should not equal to tertiary alkyl group. R dash should not equal to tertiary alkyl group. Very important. See, in place of R dash, you should not take vinyl, you should not take aryl, you should not take tertiary butyl group. Then reaction do not take place. This is only the question coming area. Clear? Remember. Let us continue examples. Did you get this? R dash. In alkyl halide, R part is there na? In alkyl halide, R part is there na? That R part should not equal to vinyl, aryl and tertiary butyl group. Clear, all of you? Right? Okay. Let us continue examples. See, this is the shortcut mechanism. This is like SN2 fashion. Right? Backside attack takes place and X leaves. Clear? Right. Shall we go to next page? All of you. Okay. Right. Just tell me. Yes. Look at this, all of you. CH3ONA, CH3CH2Cl. This is alkyl halide. This is sodium methoxide. Oxygen with negative. Okay, sodium is having positive. This is positive and halogen is negative. Partial negative, partial positive. Okay. Look at this. This oxygen with negative attacks alpha carbon. Remember, here you have two carbons. Clear? So observe carefully. Oxygen is attacking alpha carbon only. Alpha carbon means the carbon which is directly attached to halogen. That is important. Clear? Some students will attach here. That is wrong. Where we have to attach this oxygen? We have to attach the oxygen to the carbon which is directly connected to halogen. See this one, right? Okay. At that time Cl leaves. Okay. CH3O, CH2. See, oxygen and this carbon are linking. Oxygen and this carbon, and to this carbon methyl is there. So I am writing this. Right? Ether, methyl ether. Okay, or ethyl methyl ether, both are same. Or methoxy ethane. IUPAC name is methoxy ethane. Right? Okay. Next example. CH3ONA. What about product? Can you give the product? Can you give the product for this? Yes, very good. Reaction do not take place. Why? In place of R, vinyl should not be present. I already given now. Once look at this, all of you. In the alkyl halide, this R is there now, means here R dash. This should not equal to vinyl, should not equal to aryl, should not equal to tertiary butyl. Clear? So in this example, this R dash part is equal to vinyl. So reaction do not take place. Reaction do not take place. Clear? Another example we can take similar to this example. CH3ONA. Here also there is no reaction, because in place of R dash, phenyl group is there. So this is not possible. This is not possible. Product is reaction is not possible. Clear? Right. And if I take tertiary butyl group, in this case also reaction do not take place. Tertiary butyl chloride, no reaction. No reaction. Remember these three. In the Williamson synthesis, you should not take vinyl chloride, chlorobenzene, tertiary butyl chloride. These three alkyl halides do not participate in the Williamson's ether synthesis. Vinyl chloride, chlorobenzene, and tertiary butyl chloride. Clear? Right. Did you get all of you? Bhakti. Shall we go to next page? Right. Now, once look at this very important product. Its name is anisole. Very important. Anisole. To prepare anisole, what are the reactants we have to take in the Williamson's ether synthesis? How to get anisole? See, if I take like this, CH3Cl, or if I take like this, I'll get a anisole, no doubt. Possibilities I am explaining. See here, oxygen with negative attaches to this carbon and Cl leaves. Then you will get a C. This O attaches to CH3, you will get anisole. One possibility, right, to get anisole. This combination is one possibility. Next, this is negative, this is positive. If O negative attaches to this carbon, it will go. In this case also we can get which is correct combination, 1 and 2. Which is correct combination? First one. Why? In the second one, aryl halide is present, but what is the condition in the Williamson synthesis? In the alkyl halide, R should not equal to benzene ring. Clear? Right. So very important example this is the correct combination to get a anisole. Anisole or methoxybenzene. Anisole or other name methoxybenzene. Anisole are also called as methoxybenzene. Methoxy H. Methoxybenzene. Got it? Very important example. This is about Williamson's ether synthesis. Got it? Right. Next. Shall I clear this? Williamson's ether synthesis. Right. Next, reaction with dry Ag2O. Reaction with dry Ag2O. In the flow chart I given, once you can see that flow chart. What is the product when I use dry Ag2O? Alkyl halides react with dry Ag2O. What we will get? We will get ethers. See the shortcut mechanism. I'm taking two alkyl halides. See, just a second. Rx, this is one alkyl halide. Okay, this is one alkyl halide. In the middle, I'm writing Ag2, Ag oxygen Ag, Ag oxygen Ag, plus. Guess what will be eliminated? See, Ag and X, AgX means AgCl, AgBl. Here Ag and X. See, eliminate this. Eliminate this. What are remaining? R. This is eliminated. O. This is eliminated again. R. Clear? So you will get ether. When alkyl halides treated with dry H2O, you will get ether. ROR. Clear? This is shortcut mechanism. Here AgX is eliminated. When AgX is eliminated, join the remaining part. Remove AgX here, remove AgX here, and merge remaining. ROR. Clear? In place of R, you can take methyl chloride, CH3Cl. Any alkyl halide you can take. This is reaction with the dry H2. Got it, all of you? Next, very important reactions we are going to start. Reaction with NaCl, KCl or AgCl. Reaction with the NaCl or KCl. Reaction with NaCl or KCl. See, here one important part you should know. They are asking the question about the nature of NaCl or KCl. Means what type of compound it is. There, why you are getting cyanides? They are asking the questions like this. See, NaCl is an ionic compound. Very, very important. NaCl, KCl is ionic compound and undergo dissociation into ion. So I am writing that point. NaCl is an ionic compound. It undergo dissociation. See, like this. NaCl gives rise to Na plus Cl negative. Carbon is having negative charge. Clear? Sodium is getting positive charge and carbon is getting negative charge. Right? Now, when I treat this alkyl halide with NaCl, what will happen? Look at this. Rx, alkyl halide, when treated with NaCl. In NaCl, Cl negative, carbon with negative. Attaches to this R. See the link, carbon is linking with R, X leaves. Then we will get R to the R. Which atom is linking? Carbon is linking because carbon is having negative charge. So Cn. Since carbon is getting negative charge, so carbon is giving electrons to alkyl carbon. This is positive actually. This is negative. Halogen is negative. This negatively charged carbon is linking with R. That's why RC, not Rn. Be careful. RC bond N. Clear? So this is important. Ionic nature, dissociating, that is important. KCN also similar only. K plus and Cn negative. Remaining is as it is. Okay? Right. Now entire Cn, no, carbon is having negative. Okay, that negative is on the carbon atom. Cn, but actually no. Actually, that negative is on the carbon. In the usage, we will write like that. Clear? See, this is general reaction. So remember, when alkyl halide treated with NaCl, RCl, if you get any difficulty in this explanation, at least you should remember this. What is the product when Rx treated with NaCN? You will get RCN. RCN. Very simple. Clear? Remove halogen and place CN. Remove halogen and place CN. Simple trick. Clear? Right. Let us see one example for this. C2H5Cl, ethyl chloride, when treated with NaCN or KCl, anything we can use. C2H5Cl, C2H5Cl, C2H5Cl. Let us take one ring. NaCl. In the place of Cl, Cn will be attached. Remove halogen and write Cn. Very simple trick. No need to take any risk here. Remove halogen and attach Cn. Okay. Reaction with AgCl. AgCN is covalent compound. AgCN is covalent. So covalent compound do not undergo dissociation. Covalent compounds do not undergo dissociation. Right. So we are not dissociating that covalent compound. Look at this. I am giving that AgCN. Sorry. Rx and AgCN is raised to RNC, and you can consider byproduct as AgX. This is general reaction. General reaction. See the mechanism. Let us take one example, then go with the mechanism. So it is not undergoing dissociation, right? It is not undergoing dissociation. That's why carbon is not getting negative charge. Carbon is not getting negative charge. But you tell me, this is having positive charge, carbon is having positive. This is having positive and this is having negative, right? Carbon is not having any negative charge, so there is no chance of linkage of carbon with this carbon atom. Clear? Are you getting? If carbon is having any negative charge, then that carbon with a negative links to this carbon with a positive. But in this case, is carbon atom having any negative charge? No, because it is not undergoing dissociation. It is not undergoing dissociation. If it undergoes dissociation, then carbon will get negative charge. Carbon will get a negative. Clear? Nitrogen. So in this case, nitrogen with lone pairs. Nitrogen carries one lone pair. That nitrogen, lone pair of electrons, electron density. So nitrogen with lone pair attaches to this. Clear? Then nitrogen will get 4 bonds. Nitrogen will get 4 bonds. Because nitrogen is making a new bond with carbon. Nitrogen will get 4 bonds. Around nitrogen, then 4 bonds are present. That is unstable. So this bond will shift to this side. At that time, silver will leave. Silver leaves, and that silver attacks with this Cl. Or you can do like this: Ag AgCl will be eliminated, minus AgCl, and C. What is the link? Link is in between nitrogen and carbon. Nitrogen, so CH3 NC, CH3 NC. You don't think about other things. Clear? Just where link is forming, to which atom and which atom link is forming. Link is forming between nitrogen and carbon. Okay. That is the mechanism. What is the important point? AgCN is a covalent compound. It do not undergo dissociation. When we use AgCN, we get RNC. Isocyanide is formed. When we use NaCN, cyanide is produced. Okay. Right. Shall I clear this? Next, reaction with the NaNO2. Aisha, are you getting? Reaction with NaNO2 or KNO2 and AgNO2. I am giving at a time. Explanation is same. Explanation. What I give an explanation: ionic compound, covalent compound. See, these two are ionic. These two are ionic. These two are ionic, and AgNO2 is covalent. AgNO2 is covalent. Covalent. I am giving directly with NaNO2 or KNO2. KNO2. You will get a alkyl nitrite. Alkyl nitrite. With AgNO2, you will get a nitroalkane. 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 What is the relationship between these two? These two are which isomers? And before that also, what is the relation between cyanide and isocyanide? Cyanide, isocyanide. This is isocyanide, it's functional group isomers. Cyanide and isocyanides are functional group isomers. Similarly, alkyl nitrates and nitroalkanes are also functional group isomers. FG. Functional group isomers. Very, very important. You will get these type of questions. They will give like this. CH3Cl, NaNO2, this is A. AgNO2 B. What is the functional group relation between A and B? Like that questions also you will get. Both are functional group isomers. With NaCN and KCN, cyanide is formed. With AgCN, isocyanide. So cyanide, isocyanide. RCN, RNC are functional group isomers. Previously also we can write the relation there. Clear? Have you copied? Completed? Right. Yeah. Okay. Next, reaction with magnesium. Reaction with the magnesium metal. Magnesium metal. Alkyl halides react with the Grignard reagent to form RMgX. What is its name? Grignard reagent. Grignard reagent. See, dissociation of Grignard reagent is very, very important. RMgX dissociates into R negative and MgX positive. R negative and MgX positive. Example, methyl chloride when treated with magnesium metal it forms methyl magnesium chloride. See the general name alkyl magnesium halide. Alkyl magnesium halide is the general name. Alkyl magnesium halide. Methyl magnesium chloride. Methyl magnesium chloride. Dissociation reaction is very important. How it will dissociate? R negative, CH3 negative and MgCl positive. This is very important. In the coming chapters, upcoming chapters, alcohol, ketones, we use this Grignard reagent. You should know how to dissociate Grignard reagent. Remember, generally carbon will get a positive, but in the Grignard reagent, carbon will get negative. Note down some other examples. How to write Grignard reagent here? Just write like that. Okay, metal will come in the middle, halogen at the end, and R group at another end. Magnesium in the middle. Similarly, chlorobenzene, or you can take bromobenzene also. Phenyl magnesium bromide. Phenyl magnesium chloride, sir. Phenyl magnesium chloride. Are you getting, all of you? Once look at this, can you give the answer for this? Anybody? One mole of magnesium. This is only 1 mole. You tell me, which halogen react with magnesium? Chlorine or iodine? Guess. In the previous slide I took one halogen only. Here I took 2 halogens, chlorine and iodine. Which halogen reacts with iodine? Why iodine? Yes, iodine is having leaving ability.